So it's section 3.4, which the title here is Exploratory Data Analysis. Section 3.4 is going to be the very last section in our first unit before exam 1. So exploratory data analysis refers to basically two things in this section. Number one, something called a 5-number summary, and number two, something called boxplots. So we want to get some terminology down first. So first of all, we want to talk about what is a first quartile. A first quartile. So first quartile is what we want to introduce. First quartile, that's represented with Q1. Anytime you see the symbol Q1, that's the first quartile. So first quartile is a number or a value that separates 25% of the data from the upper 75% of data. So 25% of the data is at the first quartile or below the first quartile. Also, it's called the 25th percentile, the 25th percentile. Now, second of all, we have something called the second quartile. The second quartile, we call that Q2. Q2 is just a fancy name, or the second quartile is just a fancy name for the median. The median, or you could call it the 50th percentile as well. So 50% of the data is at or below this particular number, Q2, the second quartile, or the median. So we're already familiar with median. Finally, the third quartile, we call that Q3. Third quartile, Q3. It's a number where 75% of your data is at or below this particular number. We call that the third quartile, or the 75th percentile. So these are actually measures of position, just like percentiles are, but we have names for special names for the 25th percentile. Second quartile we're already familiar with is the median. The third quartile, yeah, we have a special name for the 75th percentile, calling it the third quartile. So what we want to introduce now is the 5-number summary. So what is the 5-number summary? Let me outline this here in blue. I'll put a blue box around it. 5-number summary consists of 5 numbers. First of all, your smallest number, called the minimum. Then your 3 quartiles, Q1, Q2, Q3, and then the largest number, the maximum. So those 5 numbers make up what's called the 5-number summary. So how exactly do you do a 5-number summary? How do you find these numbers? And the very first step in doing this is to get your data in order. So step 1, get your data in order from the smallest to the largest. Then you find the median. You find the middle number, the median, which is also called the second quartile, or Q2. And after that, you break up your data sets into a left data set, everything smaller than the median, and a right data set, everything to the right of the median. And you want to find Q1 in step 3. Step 3, you want to find Q1 in the first quartile. So the first quartile, how are you going to find that? It's going to be the middle number of the subset of data below Q2. So you're going to look in your lower data set below the median, and you're going to find the middle number of that lower data set. That's going to give you Q1. And after you find Q1, you can find Q3, the third quartile. In a similar way, you're going to look at the upper data set, and pick out the middle number of that. So you're going to have 2 subsets. You're going to have a left data set to the left of the median, and you're going to have a right data set to the right of the median. And you're going to look just in the right data set when you're finding Q3. Look in just the right data set. And you find the middle number in that right data set above the median. And that middle number and the right data set is going to give you the third quartile, Q3. And finally, what you'll do, you'll just pick out the minimum and the maximum, and that'll give you all your 5 numbers, the minimum and the maximum. That concludes it. So Q2 is first, then Q1, then Q3, then the min, and then the max. So that's all the 5 numbers. So that's what we want to do. We want to do some examples. It's not hard. It's pretty easy once you get it going. Let's see an example here. 13 baseball players. Runs batted in, called RBIs. RBIs are runs batted in. 13 baseball players, runs batted in, are listed below. 67 runs batted in, 55, 40. So this would be like in a single season: 49, 101, 57, 104, 72, 83, 44, 51, 55, 80, and 66 runs batted in during a season. Complete the 5-number summary for the data set. The very first thing we've got to do is put these numbers in order from smallest to largest, put it in ascending order. Looks like the smallest number is, no, not 49, it looks like 44. Yes. Then 49. Then I want to say 51. What comes after 51? 55 comes twice. 1, 2. So you have to write it down twice. 57 looks that way. What after 57? Looks like 66, and then 67. 72 would be next. I think 80. 83. 101. And 104. I think I got everything. Let me count. I'll count down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, all 13. Okay, so the first thing is to find the median, the middle number. So since we have 13 numbers, an odd number of data values, we can count 6 from the left, 6 from the right, and there's going to be 1 left directly in the middle. So let's count. 1, 2, 3, 4, 5, 6. There's your middle number. And then on the other side, you should have 1, 2, 3, 4, 5, 6. So the first thing we're finding is the median. Q2. 66. It's equals. Should be an equal sign. So now what we're going to do, we're going to separate this into 2 data sets. So I'm going to make a little bar here. And we're not going to include 66 in the lower data set. We're not going to include 66 in the upper data set. So you're going to have 2 data sets. We're going to have a lower data set here, everything below 66. And then we're going to have an upper data set here, everything above 66. So to find Q1, the first quartile, we're going to find the middle number of the lower data set. So how many numbers do I have here? I got 1, 2, 3, 4, 5, 6. So since I have an even number of numbers, I have to get the ones closest to the middle. So I'm going to take 3 on one side, 3 on the other side. So I'm going to take 51, 55. So 3 into the left, 3 into the right. I'm going to find what's in between 51 and 55. So I'm going to add those together, 51 plus 55, and divide by 2. And basically average them together. So 51 plus 55 divided by 2. That's, what is that, 106 divided by 2. So that tells me that Q1 is, what's 106 divided by 2? I believe it's 53. And that gives me my first quartile. Okay, so you want to do a similar thing, but with the upper data set to find the third quartile. So let me scroll a little bit. Can I write third quartile? Third. Quartile, I'll call it Q3. So look at your upper data set above 66. So we're not including 66 in this. We're looking at everything above 66. So you got 1, 2, 3, 4, 5, 6 values. So you're going to count 1, 2, 3 from the left and 1, 2, 3 from the right. And you're going to find what's halfway between these dudes. So to find what's halfway between those, you can add them together and divide by 2. Basically average the two numbers closest to the middle together. 80 plus 83 divided by 2. That's what, 163 divided by 2. It's going to give us our Q3. What's 163 divided by 2? Calculator, 81.5. Okay, we got the median, the first quartile, the third quartile. Now we need 2 more numbers. We need the minimum. Let's call it the min for short. We need the maximum. Now those are simple to pick out, right? The minimum is the smallest number. I'll go a little purple, it's 44. And the maximum is the largest number right here, 104. There's our 5-number summary. It's not quite in order, but that's it, right? You got the median, 66. First quartile is 53. Third quartile is 81.5. Minimum is 44. The maximum is 104. So we want to show you how to organize this data into what's called a box plot. A box plot. So a box plot is a way to organize the 5-number summary. It kind of shows you a visualization of the distribution of your data. So here we go. 2. So I haven't told you how to make a box plot. I'll just show you how to make one. Construct a box plot. Of the data set. Doesn't come out. Oh, come on now. Okay, so what I'm going to do, I'm going to start with a scale, a horizontal axis along the bottom. I want to look at my smallest number, which is 44. My largest number is 104. So I'm roughly going from what? About 40 to 110. If my smallest number is 44, I'm close to 40, right? And if my largest number is 104, I'm close to 110. I'm going to make a little horizontal axis here. Let's get a ruler. There's a ruler tool here on this thingamajig. And I'm going to put this along the bottom. There's a horizontal axis I'm trying to make. Okay, and what do we got here? Does this thing move? Yes, this thing moves. That's pretty cool. So I'm going to say this one here is 40, right? Our smallest number was close to 40, and our largest number was close to 110. Let me see. What do I want to make this go by 10. So let's see. I'm going to say that would be 50. 60. 70. Let's see if I can get this all on here. I use graph paper for this very reason. 80. 90. 100. 110. Okay, that works. So that means I'm going to erase this part over here that I don't need. So I decided to go by tens. 40, 50, 60, 70, 80, 90, 100, 110. You can scale however you want. You could go by 5s, or you could go by 1s if you want to write everything out. I generally like to go by 10s if I can. 10s are good to go by. You're scaling. Okay, so roughly, so my smallest number, my minimum was 44, so that's close to 40, and my largest number, 104, was close to 110. So I want to underestimate 44 with 40 and overestimate 104 with 110. So that's going to be my scaling along the bottom. Okay. Now above this horizontal axis, we want to create a box. We want to create a box with Q1 being the left side of the box and Q3 being the right side of the box. So I'm going to figure out Q1 is 53, right? Q1 is 53. Q1 is 53, so where is 53 here approximately? 53 would be approximately right here. That's going to be the left side of my box. That's Q1. Now Q3 is 81.5. Where's 81.5 here? Let me scroll up a little bit. 81.5 is going to be right about here, just a little over 80. So that's going to be the right side of your box. And then you're going to make a horizontal piece of your box and a horizontal piece of your box here. So that's our box. So the left side of the box is Q1 and the right side is Q3. So let me put here at the top of the left side, I'm going to put 53 just to tell us what that value is right there. And on the right top side, I'm going to put 81.5. That's telling us where the ends of the box are. So the left end is at 53 and the right end is at 81.5. So the left end is Q1, the right end is Q3. Now, somewhere in the middle of the box, we're going to have our median. Remember the median was 66, so I got to find 66. I'm going to put a vertical bar where the median is. A vertical bar, so where's 66? Right about here. 66. And I'm going to label that 66. So my median is a vertical bar that goes inside of the box, Now finally, what you want to do, you want to mark off to the sides of the box. You want to mark off either with a dot or a small bar, a vertical bar. I use a vertical bar. Some people use a dot. I want to mark off the minimum on the left side of the box. So let me find that. It's about 44, right? It's about right here. So right, 44 above this. And I'm going to connect this minimum to the box with what's called, we call that a whisker. We have a horizontal bar that's called a whisker. Now, for 104, that's the maximum. We want to do the same thing, but on the right side, we want to mark off 104 on the right side. The small vertical bar. Now you can use a dot. Some people use a dot, but I like to make a vertical bar myself. Okay, so that's 104. That's the maximum. And we're going to connect that to the box with the vertical bar. So here we have it. This is called a box plot. So a box plot is showing you how your data is distributed, how it's distributed. Gives you a nice vertical or horizontal image of how the data is spread out. Okay, so you can see very clearly using this what Q1 is, right? Q1 is 53, it's the left side of the box. You can see very clearly what Q2 is. Q2, the median is in the middle of the box, right? 66. Q3, that's the third quartile. You can see what that is very clearly. It's the right side of the box. And then you can see your minimum maximum right through the tips of the whiskers, the whisker tips. 44 is the minimum on the left whisker. 104 is the maximum on the right whisker. And you got to make sure you have some kind of scaling down at the bottom. You always want to make sure to do some type of number line. Now, you don't have to go by tens, but I always find tens really nice, so I go by tens generally when I can. Sometimes it's not appropriate. Maybe it's better to do 5 sometimes when you have numbers that are more closer together. Okay, so there's an example of a box plot. So the 5-number summary is graphically visualized in a box plot. We'll do another problem in our next video.